Hey everybody, welcome back. Today we're going to start talking about section 5.4, talking about complex numbers. To start today, we're going to solve the equation 3x squared plus 10 is equal to negative 26. In order to do this, we're going to use a method that we already know. We're going to end up solving it by using some square roots. So, to do that, we need to get x squared on one side by itself. First thing we want to do, subtract 10 from both sides. We're going to get that 3x squared is equal to negative 36. And then, since the x squared, or the squared only applies to the x and not the 3, we can divide that 3 away. And I can get that x squared is equal to negative 12. And to get rid of the squared, we take the square root of both sides. Don't forget, you need a plus or minus. You put the square root in, so that takes into account both sides of both positives and negatives. Now, you guys may see that we've got a problem here. We're trying to take the square root of negative 12. So, you have to ask yourself, what number times itself is going to give me negative 12? Well, since it's a negative, the only way we can get a negative when we're multiplying is to multiply opposite sides. So, if we take a positive times a positive, well, that's going to equal a positive number. If we take a positive times if we take a negative times a negative, that's going to equal a negative. And two negatives are going to multiply to a positive, and a positive times a negative is going to equal a negative. Well, the only way we can get that negative in there is if I have two opposite signed numbers, one positive, one negative. If they have opposite signs, they're not the same number. Okay, but let's just kind of move on as if it were just a positive 12. We're going to break this down just like we normally would. So, I move on, I get that x is going to equal plus or minus, well, what numbers multiply to 12 that has a perfect square? Well, I know 4 goes into 12. 4 is a perfect square, so I'm going to take 4 times the square root of 3. And in order to get the negative 12, we're just going to take the square root of negative 1. Okay, this is just breaking down square roots like we did in section 2. Simplify that down a little bit. We're going to get 2 square root of 3. The square root of 4 is 2. Square root of 3 can't be simplified down anymore. But this square root of negative 1, this is a special number in the math world. This is what we refer to as I. Okay? Whenever you see the square root of negative 1, you know that that is equal to I. What happened when they invented, or when they found I, was almost identical to what we've done here. Is they were solving a problem. They got to a point where they couldn't take the square root of a negative number, so they said, well, let's just pretend like we could. Just kind of like we did with the 12, they broke it down, and they just had that square root of negative 1. So instead of writing that over and over again, they just denoted it as I. So, going back to our problem, we've got plus or minus 2 square root 3I. Or some people like to write it with the I with your whole number, so plus or minus 2I square root 3. I'm not too picky. Just make sure that I know that that I is not inside your square root. Just one more kind of quick example on how you can break these down. If I give you the square root of negative 4, that'll break down into the square root of 4 times the square root of -1. So whenever you're taking the square root of a negative now, we'll take out that square root of -1. So square root of 4 is 2. Square root of -1 is I. So the square root of -4 is 2I. So we've got some properties of the square root of negative numbers, just like we're working with, where if we have the square root of a negative number, you can take out that square root of -1 and make it I. So square root of -5 is I times the square root of 5, or square root of 5I. Then one thing that you should be aware of, if you have the I times the square root of some number, it is just going to equal negative that number. So if you have I times the square root of 5 squared, this squared will get distributed to both the I and the 5. I squared is just -1. Square root of 5 squared is 5. So you end up with a -5. Another way you can do that is put the I back in there to get the square root of -5 squared, which would again be -5. Square roots and squaring undo each other. Some definitions for you. We have what we call a complex number. So this is a number that is written as a combination. That's not going to fit. Of a real part and an imaginary part. When I say imaginary part, no, I do not mean that it is just made up. That is just what it's called because it's not real. So what I mean by standard form, and I'll kind of show you what I mean by the real part and the imaginary part, where I have, when I talk about standard form here, this is standard form, and this is how I want you to write all of your complex answers. It's going to be A plus BI. So A is going to be your real part. The BI is going to be your imaginary part. So an example of this could be 2 plus 3i. So 2 is just a regular number. This is what you guys have been working with. You guys worked with real numbers your entire life up until now. So the 3i, we call it imaginary because it's not a real number. It falls outside of those circles, if you remember doing those at the beginning of the year, that we talked about the different types of numbers. Those were all real numbers. Now we are branching into the complex numbers where we've got that imaginary part. And last but not least, the imaginary number is the imaginary part of a complex number. So, for instance, if we look at our example from before, 3i is going to be the imaginary part, so 3i is an imaginary number. Again, no, it's not made up. It's not that it's just made up like your imaginary friends. It is imaginary because it's not real, as opposed to the 2, which is a real number. So we've done a lot of theory explaining what it is, but what are we really going to do with these? Today, we are just going to talk about adding and subtracting. For the most part, you can really think of the imaginary part of your complex number as just a variable. So if it makes you feel better, you could swap out the i's for x's, and adding and subtracting would work the exact same. So you are just going to collect your like terms. So in A, 4 and 3, I add those together to get 7. If I take negative I plus 2i, well, that's going to give me a positive I, and that's what I get. B, we're going to talk about subtracting. I'm not good with subtraction. So what you can do when you subtract is you can change it to an addition problem. So I distribute this negative to everything inside here. So I get 7 minus 5i, and I'm going to change that subtraction to a plus, and then I'm going to take negative 1 plus 5i. And now it's the same process. You look at your 7 and your negative 1, you're going to get 6. Then you look at your negative 5i plus 5i. Well, those cancel out, so you get 0i. Multiplying by 0 still holds, so you just end up with the number 6. This is a complex number that when subtracted turns out to just be a real number. Again, for C, I'm going to distribute this negative and change to an addition problem. This is the same process, it's just a little bit longer problem. So I'm going to get 6 plus 2 minus 9i plus negative 8 plus 4i. And now we collect all of our like terms. We're going to collect all our real parts, our 6, 2, negative 8. 6 plus 2 is going to give me 8, minus 8 is going to give me 0. And if I look at my imaginary part, I'm going to take negative 9i plus 4i. That's going to give me negative 5i. And 0 minus 5i is just going to give us a negative 5i. So this one just ends up to be an imaginary number. So we've got a complex in A, we've got a real number in B, and we've got an imaginary number in C. Hopefully this makes sense to you guys. We'll get lots of practice with this in class, so let me know if you guys have questions, and we'll get everything squared around.